All right, let's take a look at multiplying and dividing and simplifying. So we're still talking about rational expressions, which means fractions. So let's kind of go back to some that we're more familiar with. Here, I'm going to add the top two, get 14 over 12, and then I'm going to reduce that. So because this is 2 times 7, and this is 2 times 6, the 2's cancel, and I would get 7 over 6, even though it looks like a 0. Here, be careful, because you can't really reduce this. I always call this triangle reducing. So the only way you can reduce this is if something comes out of all three corners. The temptation is to cross the x's off, but because the x plus 2 is one thing, it's attached with that adding, you really can't reduce this. So you would just keep it as x plus 2 over x. There's nothing else to do. Here it tells you to take 2 times 12, which will turn into 24. But if you look, there's a 12 on the top and the 12 on the bottom. So I'm just going to end up with 2. All right. And then here, same thing. I have an x on the top and x on the bottom. Here I can cancel them out because there's not addition like there was in here. Adding and subtracting means you cannot cancel out just part of that. Either the whole thing goes or not at all. So this one actually turns out to be 2 as well. Okay, so when you go to simplify, and this is really going to be the core of what we do for all the rest of it too, that means that you're going to factor the tops and bottoms, and then you just like cancel anything that's common, just like we did up above. So we're going to cancel the common factors. You're basically reducing it. So like up here, we canceled the common factors. Here, we canceled the common factors. So what we're going to do is find out what factors we have. Now, like this one doesn't have adding and subtracting, so we've actually done this before. All I'm going to do here is reduce this part, and I can take a 5 out of both. So this would turn into 3/5. Then the x's we've done before, 8 on top with 2 on the bottom, means you're going to have 6 left on top, 3 on the top, and 10 on the bottom. A difference of 7 will be left on the bottom. But now when you see that it's got adding and subtracting in it, then you think, okay, well, I have to factor them. And the first step in any factoring is the gotta check first, the greatest common factor. So in the top, I can take out a 3, leaving me with x plus 6 when I divide it out of there. And on the bottom, I can take out a 5, leaving me with x plus 6. So factors are multiplied. So 3 times x plus 6 and 5 times x plus 6. So since these are completely identical, you cancel them, and what you're left with is the simplified or reduced version. So it's like this one is already factored, so simplifying is just going to mean getting rid of the 2 that are alike, and I would just be left with the x plus 5 is my simplified or reduced version of that. Here, it is not factored yet. The top is a GCF situation where I'll pull out a 4. And the bottom is not. The bottom is where I'm going to have to go to my blue card and figure out how do I make 15. 1 and 15, or 3 times 5, needed to subtract to be 2, so I'm going to have to use these guys. And in order for it to be negative 2, I'll need negative 5 plus 3. But then this x plus 3 cancels that x plus 3, and I'm left with 4 over x minus 5. So simplifying is reducing, and basically that's what we're going to do when we're asked to multiply. This looks really intimidating, but it's really not, because really all I'm going to do here is I'm going to do what I did up above. But now I have more to manage, so I'm going to factor all the tops and bottoms. And then anything on the top anywhere can cancel anything on the bottom anywhere in the problem. Just like in chemistry, if you have that where you're doing the dimensional analysis. So then I'm going to cancel common factors. So honestly, it looks the same as the instructions for simplifying. It's just you have more to manage. So here, this one again, there's no adding or subtracting. So I'm just going to go ahead and multiply the 8 and the 7 together. And I'll have 54. And then I'm going to have these x to the 3 and this x to the 4 goes together to be x to the 7. And this y to the 1 goes with the y to the 3 to be y to the 4. So we're just remembering our powers. On the bottom, I have 2 times 4, which is 8. And then I just have 1x and y squared. Sorry, it made it look like I made a negative x. And then I'm going to do what I did up above. Here, I can take out a 2 and get 27 over 4. Here, I have 7 on the top, 1 on the bottom. That's a difference of 6, and they'll be on the top. Here, I have I should have a y to the 3rd. I'm looking at the filled in notes online, and there's something fishy about that. So I should end up with 1y because 4 and 3, there's a difference of 1, and it's on top. If you're looking at the filled in notes, I made the y touch the 3 in the bottom. It looks like a 5, and I made a mistake, so I'll have to fix that. This one, again, looks overwhelming, but what we have to do is factor each piece. So let's factor this. I need 15 in a way that subtracts to be 2. So that's going to require a 5 and a 3. To get a negative 2, I'll need a minus 5 and a positive 3. How about if I factor this bottom left? In the bottom left, I need a 5 in a way that subtracts to be 4. So the only way to get 5 is 1 times 5. For it to be a positive 4, I'll need a plus 5 and a minus 1. For the top right, I'm going to have to find 20 in a way that subtracts to be 1. So I'm going to use 5 and 4. To get a positive 1, I'll need a positive 5 minus 4. And then the bottom right, that is the difference of 2 squares. And you just got to kind of get to a point where you're getting good at that. So you know, hey, that would be the sum and the difference of what x squared and 9 are the squares of. So like this is the square of x and this is the square of 3. So this is all multiplied. So just like I said, like in chemistry, if you have any unit on the top and then the same unit somewhere on the bottom, you can cancel them out. So for example, this x plus 5 can cancel this one over here. It doesn't matter like which part they're in. What else? I have an x plus 3 here and an x plus 3 on the top. So what I have left on the top is an x minus 5 and an x minus 4. What I have left on the bottom is an x minus 1 and an x minus 3. So it simplified a bit, but it didn't break down to like something really teeny, and that's okay. So simplifying and multiplying are really just the same thing. There is just a little bit of a twist, kind of literal twist, when you're dividing. Dividing can kind of strike fear in the hearts of people, but you're not really dividing. What you're going to, keeping in mind that dividing is the same as multiplying by the reciprocal. So if I'm going to divide by 2, oh my gosh, if I'm going to divide by 2, that's the same as multiplying by a half. So what we're going to do instead for dividing is we're going to multiply using all the rules that we just did up above, so factor and whatnot, but you're going to multiply by the reciprocal of that second function or of the second fraction. So you're going to, and reciprocal means you're going to flip it over. You're still going to factor everything, you're still going to cancel, so it's all the same math. Now this doesn't have any adding, so I'm really not going to factor. I'm just going to put it all together. So here, I'm going to keep my first one the way that it is. But this is the one that I have to flip. So I end up with 20 on the top, y6 on the top. And then everything on the top moves to the bottom. So 27x to the second, y to the third. Now I can just multiply the numbers on top. I only have that x to the 12, but with the y's, I have a 1 here and 6 to the right, so I end up with 7 of those all together. 9 times 27 turns out to be 243. I have x to the 5th and then also x to the 2nd, so I end up with x to the 7th. I wrote x there instead of a y. And then when I go to do the y's on the bottom, there's only that y to the 3rd. So this I can reduce. I can use my calculator, except it doesn't actually reduce. Nothing goes into both. So I end up stuck with that fraction. 12x is on top and 7 on the bottom. That's a difference of 5, and that'll end up on the top. 7y is on the top and 3 on the bottom is going to be a difference of 4, but they'll also be on the top. So this is my division answer or quotient, but I really never divided. I just multiplied by the reciprocal. So same thing here. I'm going to multiply by the reciprocal of this. So as I go, I'm going to go ahead and pull the GCF out of this bottom left, and I'm going to take out the 2, leaving me with x minus 5. Now I'm going to flip these around. So this x squared minus 11x plus 30 is on top, and the x squared minus 6x is on the bottom. So I need to factor those also. So in the top, I'm going to need 30 in a way that adds up to 11. So 5 times 6. I need it to be a negative 11. So they both have to be minus. On the bottom here, now that I flipped it over, I have a GCF situation where I can take out an x, and that will leave x minus 6. So here's all my pieces to that. And this x minus 5 cancels this one. X minus 6 cancels this one. This 7 times x, the x will cancel this x. So when I'm done, the only thing I have left on the top is the 7, and the only thing I have left on the bottom is the 2, which is entirely possible that you get a number answer. All right, this one looks really confusing, but it's actually not that terrible. This is over 1 right now, and since it's division, we're going to flip it. So the first thing I'm going to do is factor this top left. I'm going to be looking for 24 in a way that adds up to 14. So if I go to my blue card, I'll find 12 times 2. To get a positive 14, they'll both need to be positive. Now I'm going to flip the other side over. I'm going to have 1 over 5x plus 10. But I can, for 5x plus 10, I can take out a GCF and be like, I'll pull out a 5, leaving me with x plus 2. Because that's what 5x plus 10 would factor into if I pulled the 5 out. So my x plus 2 cancels with this x plus 2, but that's all that cancels. So I end up with x plus 12 over 5x. And that's it. So really all of these are the same thing. Factor everything and see what cancels. When it's multiplying, it's just more, but you're going to factor everything and see what cancels. When it comes to dividing, it's just going to be flip the second one and then factor and see what cancels. So it's really the same process. The only real problem is going to be if you struggle with factoring. So hopefully that is not the case.